Hello everyone, welcome to Ways to Learn. In this session, we will see an introduction to C++ and basic concepts of object-oriented programming language. C++ was developed by Johnny Stubstrup in the year 1982 at AT&T Bell Laboratories. C++ is an advancement of C language. You all know that the C language is a procedural-oriented language. A procedural-oriented language means the program is decomposed into number of functions. We will give importance to functions rather than the data. The data here will be moving freely. So in order to provide a security to the data, a C++ was created with object-oriented programming. So here C++ focus on objects and classes. In C++, data and functions are wrapped together as an objects. So one object cannot access the data directly, but through the functions they can access the data of another object. So this is how the data security is ensured in C++. Features of OOPS. Object-oriented programming language provides an easier and faster way to execute your code. It provides an importance to the data rather than your procedure. A program is divided into number of objects. The object is a combination of data and functions. The data cannot be moved freely around one object to another object. So they can communicate only through the functions. So here it provides a high security to the data. So let us see some of the benefits of OOPS. Some basic concepts of OOPS are objects, classes, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, and message passing. The object-oriented programming language's main concept is objects. The objects are the basic runtime entities. They are represented as a user-defined data type. The object is represented as a specific item that exhibits the data and behavior of a class. Once a class is created, you can have any number of copies of object. So object doesn't have the special behavior. It acts like a class. So we can say objects are the copies of class. So next we will move on to classes. So now you all know about what is object. So object is a blueprint of a class. You can create class with the members of data and functions. After creating a class, you can create any number of objects of that type class. See, here is an example. Shapes is a class name you had created. Then you can create an object, shape object. You can create any number of object of that type shape. So class acts as a data type. You can create any number of variables based on that data type. The next concept is data abstraction and data encapsulation. They both are different concepts. First, we will look into the details of data encapsulation. Data encapsulation is like a capsule. You all know a capsule is a small box which contains a mixture of ingredients. The same way, the class acts like a small box or a container which contains its members. Here the member is data and functions. So now you know what is data encapsulation. Encapsulation means wrapping up of data and functions together in a class is known as data encapsulation. So how you will achieve a data hiding? The private data of that class cannot be accessed by other classes. It can be accessed only by the functions of the same class. So this concept is data hiding. So data hiding means hiding the data from the direct access of other classes. So it is data hiding. So data hiding means we are hiding the data. Next is data abstraction. The data abstraction means a process of providing essential details to other classes by hiding the internal details. Here we will provide an information by hiding the internal details. It is not like a data hiding. Data hiding, we will completely hide the data. Here we will provide the necessary informations to the classes by hiding the internal details. We will see in the later sessions how we will achieve this data abstraction and data encapsulation in our concepts, in our programs. Here the example for data abstraction is 5 power 3 equal to 125. So here all the internal calculations has been hidden. Only we will see the result as 125. So this is what the data abstraction and data encapsulation. Now let us see inheritance. Inheritance is a process by which an object of one class can acquire the properties of other class. So how it is possible? Take an example, a family. If in a family, a father will have the proper qualities of his father and his own qualities, right? The same for son. Son will have the qualities of father, grandfather, and additionally he will have some other properties. The same here. See the example in the class birds. Birds is a parent class. In the parent class, they have some data members and member functions. So we can create a another class. Okay, in that class, that is subclass. In that class, we will have flying birds and non-flying birds. The flying birds will have its data member, that is minimum distance and food, and with the details of wings, legs, eggs in the parent class. So in non-flying birds class also we will have weight as its data member with the additional of wings, legs, eggs as a data member which is given in the base class. So we can acquire the properties of another class using the concept of inheritance. We don't want to declare repeatedly. Here the repetition is avoided. So this is the concept of inheritance. Next we will move on to the concept of polymorphism. Poly means many, taking more than one form. So one operator can take many forms or one string can take many forms. So this can be achieved by two ways: operator overloading and function overloading. So operator overloading means an operator is overloaded. The same thing. One operator is overloaded with different concepts. Example, 5 plus 10, a plus operator, that is addition operator here. 5 plus 10, 15, answer. Next one, poly plus morphism. Here they are strings. So what we have to do? We have to combine, not add. Combine the two strings, polymorphism. So the same operator plus acts differently on different data types. So this is operator overloading. The same thing for function overloading. Let us see what is this. This function overloading is making the use of same function to perform different tasks. Like an example, add. Add is a function uh, for adding two numbers or three numbers, something like that. Okay, so here see an example, 5 comma 6. It adds two integer data type values, and the next one add 5.6, 7.0 and 8.0, which calls a function to add three variables, three numbers of float type. So here the function name is same, but the data which is given in the parameter list is different. So it acts differently based on the data and members of the data, numbers of data. Now let us see what is dynamic binding. Dynamic binding means binding of procedure call to the code is called dynamic binding. So we can bind member functions to the code in two ways. One is compile time and during runtime. During compile time means while the code is compiled, that is, it is known as early binding. During the compilation time, the procedure is linked to the code, so it is early binding. So during runtime, the procedure call will map to its functions. So this is dynamic binding. So it is otherwise called as late binding. It is only known at the runtime or during the executing time, based on the input maybe. So an example, draw as a function, based on the input it calls it draws the circle or rectangle. Whatever the user gives, it acts accordingly. So it is called runtime binding or late binding. So let us move on to the next concept, message passing. The message passing is object can communicate with another object by sending or receiving the messages. So how we will send a message? So using a parameters. So if you want to draw a circle of radius 50, then draw is an object and circle is a call to that procedure, and 50 is an information we are going to send to that procedure. So this is how the message is passed from one function to another. Okay. So these are the basic concepts of object-oriented programming. So in next session we will see about how to write a C++ program. Thank you.